So there are two things you need to think about when you do the domain of a composition. When you do f of g of x, you get some answer here. For the domain, you are going to have to look at two pieces. You need to do the domain of the inside, the very first thing you plugged in, and the final answer. So find the domain of the inside function and the final answer. You will have to put both of those together to get the overall domain. Now, I want to caution you, I always have people that just try to look at the very end. If you do that, you will be right about 50% of the time. But you also have to look at the original function that you plugged in. Because if I said f of g of 3, the very first thing you're going to do is plug 3 into g of x. So you have to be able to put the 3 in there. And then you have to be able to get the final answer from it. So we are going to look at this. I'll give you a second to write it down. I want to look at multiple functions, so we'll probably just do b here. We're just going to do g composed with f and find its domain. So the g composed with f, that's stuff we did yesterday. So we have g of f of x. Okay, so f is x squared plus 3x minus 1. You need to put that into g. So what that means is you're going to go to g, and every time you see an x, you are going to replace it with this x squared plus 3x minus 1. So we get 2 times x squared plus 3x minus 1 plus the 3. Distribute. So we get 2x squared plus 6x plus 1. Okay, that's what we were working on yesterday. Are you guys okay with that part? Now if I want the domain of this, you are going to look two places. You have to give me the domain of the inside function, which was this, and the domain of the final answer. Now with domain, there are two things to remember. If you have a fraction, the denominator can't be 0. And if you have a radical, whatever is underneath has to be greater than or equal to 0, right? Do either of these have a fraction or a radical? So what's the domain of both of these? Negative infinity to positive infinity. So our overall domain is also negative infinity to positive infinity. So this one isn't all that interesting. Neither one had fraction or radical, so when you do your domain, there's nothing extra to do there. Let's look at this one. Write that one down all day.
Well, I mean, Autumn isn't registering that because the system is down and they've had to
See, last night I tried to log into it with my laptop and
It wouldn't work. Yeah.
well, I could get logged in, it's just asked for the class code or.
Oh, you shouldn't have to. Yeah. It's got some issues. Okay, so let's look at this f of g of x. So we're going to start on the inside. So g of x is 2 over x. I have to plug that into x. So we have 3 over x, which I'm replacing with 2 over x, minus 1. Now, is it okay to leave a fraction within a fraction? No. So I am going to have to do something about that. Now, we have a couple options. The first option is to do like you were taught in your previous math classes, get a common denominator down here. So you have one fraction, flip and multiply. The second option, I can show you a quick trick to fix it. What's my denominator that I need to get rid of down here? Okay, I'm just going to take top and bottom of this times x. As long as you multiply it on both top and bottom, it's legal. Okay? So if I multiply everything times x, 3 times x would be 3x. 2 over x times x would be 2. Minus 1 times x is x. And there you go. Now, for our domain, we are going to look 2 places. We look at the inside and we look at our final answer. When you look at this inside part, it is a fraction. You know that if you have a fraction, the denominator cannot equal 0. So x can't be 0. Right here we also have a fraction, so I know my denominator cannot equal 0. So if I solve that, that gets 2 cannot equal x. Okay, you guys all right with that? So my overall domain, x cannot be 0 or 2. You have to put both of those together. Questions right there.
Do we have to put an interval notation?
If it's just one value that x can't be, I want the interval. More than one, I've kind of let you be lax and just list them. If you were doing the interval, it would be everything from negative infinity to 0, everything between 0 and 2, and everything bigger than 2. All right. Questions there? I'm going to give you another one. Let's say okay. Let's do G composed with F and the domain for that one. So G composed with F is G of F of X. So that's G of X squared plus 1. Okay. Can I change something so this works out a little better? Can I make this a 10 right here? Alright, so I'm going to plug this into G. So if I put that in, we get the square root of 10 minus, this would be x squared plus 1. Okay, you guys with me there? What would you do? Distribute the negative. So then you have a 10 minus 1, so we get 9 minus x squared. Now it's 2 terms, so you can't do the square root of each one. So that is our final composition. But let's talk about the domain. For domain, we look 2 places. We look at the final piece and we look at what we originally put in. With what we originally plugged in, there's no fraction or no square root, so do we have to worry about that? No, that one you could put in anything. When we get to the final answer, it's under a radical, so I know that it has to be greater than or equal to 0. But remember when we talked about domain last week, I said if it's a quadratic, you can't add square roots if you have that inequality. So how did we figure out the domains for those? We're looking at the graphs. Grab your graphing calculator. Everybody needs to grab one and look at it. I want you to go to your y equals and do your 9 minus x squared. That to be greater than or equal to 0, so you are looking at where it is above the x-axis. Where is that? Between -3 and +3. So my interval will look like this. Now we have to put both pieces together, but the first one said it could be anything, so this is really all we have to worry about. So here's your domain. Everything between -3 and +3 would work. Does that make sense? Let's do the reverse here. So let's do F composed with G and its domain. So F composed with G. G was the square root of 10 minus x. If you plug that into F, F was x squared plus 1. So it would be this squared plus 1. What happens if you square a square root? Cancels. So you get 10 minus x plus 1. So we get 11 minus x. There's your composition. For the domain, you have to look at the original inside and your final answer. Now the final answer doesn't have any fractions or square roots, so it's good. But if I look here, this is under a radical, so I know that the 10 minus x is greater than or equal to 0. If I add my x over, I get 10 is greater than or equal to x, or you could write that as x is less than or equal to 10. So our overall domain, right, it's just that x is less than or equal to 10, so negative infinity to 10. This one could be anything, so I don't have to worry about that, so there's your domain. That's it. Question 6. We're going to do another one, and then I'm going to give you guys a couple. Okay. So I gave you F and G. I'm asking for F composed with F. If you have F composed with F, am I even going to use my G right here? No. So we've got F of X. So F is 1 over X plus 2. I am plugging that back into F. So F is 1 over what you put in What's wrong with this? It's a fraction. Okay. So the trick that I gave you is you could multiply by the denominator. What's my denominator?
But don't we need the minus 2 1?
Only if it's a radical. Alright, so when we do this, 1 times x plus 2 is x plus 2. What's 1 over x plus 2 times x plus 2? The x plus 2's would cancel, wouldn't they? And you would just get 1. Plus, then you have 2 times that x plus 2. So you take everything times the x plus 2. Do you guys see what I did right there? So if we just clean that up, that would be 2x plus 4, so if you add your 1, you get 2x plus 5. So I want domain. We are going to look 2 places, the inside and the final. If I look at the inside here, it was a fraction, so I know that the denominator cannot equal 0. So if you subtract, x cannot be negative 2. If I look at the final, it's a fraction, so the denominator cannot equal 0. So we're going to subtract our 5, divide by 2, and we get that x cannot be negative 5x. So for the overall domain, you put the 2 together, and x cannot be negative 5/2 or negative 2. Is that okay? What I'm going to do, I'm going to give you guys 2 of these problems that I want you to add to your homework from last night. So that handout that you did, you're going to put 2 problems on the end of that. You can ask me a question if you get stuck, and then in a few minutes we'll grade. If you get done with these 2 problems and you're waiting for everyone else, you're welcome to work on the Math Excel assignment while you're waiting until we get to the point where we're ready to grade. Alright, so on these, I want you to find G composed with F